Hi, welcome to a nostalgic ramble with me. If you don't know who me is, I have an intro video up, check it out. But yeah, I am a person, I'll give you the minimum required knowledge. Person who loves mathematics, taught mathematics at some point, and now I'm enjoying just looking at old exam papers and attempting the questions and kind of trying to think out loud as I go through them, in the hopes that, if you are a student who has looked at the same question and kind of got stumped, or you're looking for different ways to approach questions, just hoping that this process of mine can generate value for someone out there. Anyway, wow, that was a ramble in and of itself. Currently busy looking at the department's paper one from, I forgot from when. Let me just quickly look. I hope I have the title. Oh, November 2022, paper one. Right, and as you can see, we've already looked at a couple of questions in this series. So, yeah, today we are looking at question 4, 4.1 to be specific. Okay, so let's see what's going on. Sketched below is the graph of h of x is equal to 1 over x plus p plus q. So that's a hyperbola. Write the asymptotes of h intersect at the point 1, 2. So that tells us what each asymptote is. So this asymptote is x is equal to 1, and this asymptote is y is equal to 2, which also tells us, if we think of our very, very basic hyperbola as y is equal to 1 over x, the asymptotes tell us how much this graph has been moved, left or right, up or down, to become this guy. So those are just all things to keep in mind. Very first question says write down the values of p and q. So that's, indirectly asking us how much was the very original, very basic hyperbola moved in order for us to get to this. And the answer is that this current hyperbola h of x, let's write that, is equal to 1 over, and we can see that, originally this asymptote was here, right? So it has moved 1 unit to the right, which means we have 1 over x minus 1, and this asymptote used to be over here, so it means it has moved up by 2 units. So our graph has moved up by 2 units, so that's a plus 2. And so therefore p is equal to negative 1 and q is equal to 2. Okay. As per the norm, just going to double check with the memo before I go too far. And yes, we are in agreement. Right, the next question, so that was question 4.1. 4.1.1. 4.1.2. Calculate the coordinates of the x-intercept of h. Okay, so x-intercept occurs when y is equal to 0. So we want to see where 1 over x minus 1 plus 2 is equal to 0. I'm going to try and do as much of this in one line as I can. So we can then just rewrite the left-hand side with a common denominator of x minus 1, right? Because remember, 2 is just the same as 2 over 1. So our common denominator would be x minus 1, and in order to get this to be x minus 1, I'd have to times top and bottom with x minus 1. Right, so that is equal to 0. Time to shrink things. Ooh, just grazing that little p there. Don't know don't want to shrink it. Right, so that becomes 1 plus 2x minus 2 over x minus 1 is equal to 0. And the only way that this can be true is if this over here is equal to 0. And of course, there's just an unspoken restriction that x should not be equal to 1. I'll just kind of note that in a corner somewhere. Right, if x is equal to 1, then our denominator would be undefined, and we don't want that. Right, and so that implies that 2x minus 1 is equal to 0, and that implies that 2x is equal to 1, and that implies that x is equal to a half. Yeah, I don't think I'm going to manage to fit that onto the previous line, but yeah. Okay, so we know that the x-intercept, therefore x-intercept happens at a half and 0. So that would be this guy over here. I'll just mark him in blue, and yeah. Right, then the next question says, write down the x-coordinate of the x-intercept of g if g of x is equal to h of x plus 3. So the important thing here is that this h of x plus 3, what does it mean, right? What it means is we are taking the function h, or the graph of h, and we are going to move it 3 units to the left, right? Adding to the input moves horizontally, plus 3 moves us to the left, minus would move us to the right. So we're taking this whole setup and we are moving, well, not the minus the axes, those stay in place, but the graph we are moving 3 units to the left. So that means the x-intercept will also move 3 units to the left, and as such, the x-intercept of g would become a half minus 3, which is the same as negative 5 over 2 and 0. Okay, I haven't checked my 2 answers so far. Yes, both are correct. Cool. Then the last one, well, not the last one. I think there's another question after this, which I didn't copy over. Anyway, okay, I will. Is there? Wait, let me double check. Yes, there is another question that I forgot to copy over, but anyway, I will copy it after this guy, 4.1.4. So, the equation of an axis of symmetry of H is y is equal to x plus t. Determine the value of t. Okay, so we know that our OG hyperbola y is equal to 1 over x has 2 axes of symmetry. It's got y is equal to positive x, and then the other one, which is y is equal to negative x. Right, let me just draw in our hyperbola. Looks like that. Right, so when this hyperbola is moved, oopsie daisy, go back, is moved up or down, left or right, so do these axes of symmetry. So however much the hyperbola is translated, we also then translate the axes of symmetry accordingly. In this case, we are specifically being asked about the axis of symmetry that has a positive gradient, right? Y is equal to positive x. So how we can then figure out the value of t, there's a couple of ways. I'll show you 2. So the first way is to apply the same translations that were applied to the hyperbola, apply those to the axis of symmetry. So in our case, our hyperbola got shifted to the right by 1 unit and then shifted up by 2 units. So then you do the same thing to the axis of symmetry. So that would be y is equal to, and then you say x minus 1 plus 2. So shifted to the right by 1 unit, shifted up by 2 units. So that will be y is equal to x minus 1 plus 2, which is just 1. And so therefore your t is 1. So that's the one way you could do it. Otherwise, you could use the fact that, okay, we do know the gradient of this line, it's just 1. And then we also know that it goes through this point over here, the point where the asymptotes intersect. Likewise with the y is equal to negative x1, also goes through this point. So we can then substitute this point into the equation to figure out t. So we could sub in the point 1 and 2, and so we would have 2 is equal to x plus t, and then we can see from there that t is equal to 1. So those are at least 2 ways that you could figure out the value of t. Okay, and now for the question that I forgot to copy across. So we're going to need the diagram probably, maybe. And then the question. Okay, so the question says, determine the values of x for which 1 over x minus 1 is greater than or equal to negative 2. So I'm just going to note to self that we did find that h of x is equal to 1 over x minus 1 plus 2. So with these questions, you kind of want to see, well, how is this related to this, the place where we started out? You can see that this is actually the same as saying 0 is smaller than 1 over x minus 1 plus 2, right? If we add 2 on both sides of the inequality. So we are effectively asking, where does h, the function h, give us y values greater than 0, right? Where does this function produce y values that are greater than 0? So let's see visually where that is. That would be, so these are all greater than 0, these y values, and then these are also greater than 0. As for down here, right, these y values are smaller than 0. So we don't care about that. What we care about is which x values give us this part of the graph and which x values give us this part of the graph. So there's 2 regions, right? The first region I'll look at is this one, because that's pretty easy. That's everything from the asymptote onwards, right? So if I choose any x value greater than 1, then h of x will give me a positive number, right? And always with these inequalities, when you give an inequality as your answer, you must always think about whether you need to include the boundary or not. In this case, we can't include x is equal to 1 because at that point the function is undefined. It's got an asymptote, so we can't have x is greater than or equal to 1. It has to be strictly greater than 1. Now we want to describe this region of the graph. All right, so that's the one answer. Then here, remember we found the x-intercept, we found it to be a half in the previous question. So this means that for any x value smaller than a half, my function gives me positive y values, right? Anything between a half and 1, my y values are negative. So x should be smaller than a half. And again, do we want to include the boundary a half? So when x is equal to a half, h of x is equal to 0. The y value is 0. And we are looking for places where h of x is greater than or equal to 0. So that means we should include a half in that solution. Let's see what the memo thinks of our efforts. So for the previous question, we did get t is equal to 1. And then for this question, right, we do get the two possibilities being x smaller than or equal to a half, or x greater than a half. Cool. Thanks for stopping by, and see you again another time, hopefully for another ramble.